In example 3 and 4, we have variables now involved, and then we're also going to do some solving as you go into this assignment. When you have variables, we don't know what the variables stand for, so this is kind of important. When we have the square root of a squared, most people put a and they think that they have the right answer. That's partially right. However, a cannot take on a negative value, so we would have to put on the absolute value of a as our answer. This is kind of tough to explain in a video, but if a took on a negative, it becomes squared and get positive. Your a that you started with would have never, you can never have a radical equal a negative number. It's an even index. Okay, so that's why I had to put absolute value of a. In b, I have the square root of a to the fourth. That's going to be a squared. A squared times a squared is a to the fourth. Now, a lot of people would put absolute value on this one, and I won't count it wrong. I'd have a hard time counting it wrong. But we don't really need it. So if you ever check this in the back, you don't need an absolute value when it works out to be squared. Because when you square something, it's going to be positive no matter what. So when I square a, it's going to be positive. I don't have to worry about the absolute values on there. So some of these you'll need absolute values if it works out to be an odd exponent. If it works out to be even, you don't have to have absolute value. Here we have an odd index, so we have a 3 and a 6 power on the inside. A squared is what the answer to that would be, because a squared times a squared times a squared is a to the 6th. And since this is an odd index, I don't need absolute value. You only need it on even indexes, like this one right here. It's 6th root, 6th power. That would give you a, and you need the absolute value because the index was even. So you're going to kind of stumble your way through those. They're one-line answers as you come to them in the homework. I'll be happy to go over them with you if you can't find the answer in the back. So, okay, last one, example 4 here. We're now solving. Your objective is going to be to get the x by itself. Typically in the past, we've had to factor things like this, but now we can use radicals. This is going to be especially handy as we make these more and more difficult. The problem here now in this first one is when I get the radical by itself, I can undo the squared with the radical, but I can't take the square root of a negative 4. Now is a great time to use the no real solution symbol because we are trying to solve. So no real solution, you can't take the square root of a negative yet. 5b will, or excuse me, example 4b will work out better. When you go to subtract the 1, you have 5x squared equals 15. You divide by 5, you get x squared equals 3. And you take the square root. Now there's something we didn't do in example 1 that we should have. I don't know if you caught it. But when you put a square root in the problem, you have to put a plus and a minus. There can be both a positive and a negative root. So when I put the square root in, I put plus and minus. That also helps us satisfy the fundamental theorem of algebra, which says we have to have the same number of answers as our highest exponent. Highest exponent of this equation was 2, and I have 2 answers, a positive square root of 3 and a negative square root of 3. So it's important to put that plus and minus in there when you're solving. So this has been a quick review of radicals, and I hope it takes you back to Algebra 1 and you remember some things from that class. I'll give you a few to practice, and I'll address any issues on those as you have them.